Good day, everyone. We are from Group NBCS 22308A from Group 3, and we will be presenting our project title Sentiment Analysis of Sunway Lagoon Theme Park. And for this part, I will be introduce all the team member from this project team. So myself is Muhammad HAIQAL, and I'm the team leader. For the next part is Nur AZIEMAH. Is responsible for the data analysis, and Nur HAFIZAH AYUNI is responsible for the reporting and documentation. Together, we conduct the data analysis and sentiment classification for this project. For this slide, we're talking about the summary of our study. So this project customer review of the Sunway Lagoon theme park collected from the Google review, Clock and TripAdvisor. The review are classified into positive, negative, and neutral sentiment using machine learning technique. The main goal is to understand customer satisfaction, identify common issue, and support data-driven decision to improve service quality and visitor experience. Problem statement. Sunway Lagoon received 1,000 of online review across multiple platforms. However, manual analysis of this unstructured review is inefficient and time-consuming. As a result, important service issue may be overlooked. Therefore, an automated sentiment analysis system is needed to extract insight and support effective decision making. Project objective. The objective of this project are to collect customer review from the Google Review, Cloak, and TripAdvisor. Next, the review are pre-processed and classified into positive, negative, neutral sentiments. We aim to build a machine learning model with at least 70% accuracy. Finally, the results are analyzed to provide insight and the support that support service improvement and management decision making. Background of study. In the tourism industry, online reviews strongly influence visitors' decision and satisfaction. Sunway Lagoon, as a major theme park in Malaysia, received a large volume of customer feedback across multiple platforms. Sentiment analysis help transform this unstructured review into meaningful insight, allowing management to understand visitor satisfaction and identify area of improvement. For the literature review, based on the previous study, sentiment analysis is widely used in the tourism industry to measure customer satisfaction using online review. Research show that machine learning model combined with IDF provide good accuracy for the text classification, especially for medium-sized datasets. Although deep learning models such as LSTM and BERT achieve higher accuracy, they require more data and computational resource. Therefore, machine learning-based approach are suitable for this study. What is sentiment analysis? Sentiment analysis is a natural language processing technique used to identify opinion expressed in a text. In this project, we classify customer review into three categories: positive, neutral, and negative. Positive review indicates satisfaction, neutral review contain mixed or factual information, and negative review highlight issues such as waiting time, or maintenance problem. This slide presents the overall methodology of our project. First, customer review were collected through web scraping from the Google Review, Cloak, and TripAdvisor. Next, the data was pre-processed by the cleaning and standardizing the review text. The review were then labeled into positive, negative, neutral, and neutral sentiment categorized. After that, machine learning model were trained using the labeled data. The model were evaluated to select the best performing one and finally used for sentiment prediction. Dataset overview. Our dataset consists of 2,513 customer review collected from Google Review, Cloak, and TripAdvisor. The review focus on the Sunway Lagoon theme park and are written in English. The data is stored in the structured Excel format and used for the sentiment classification into positive, neutral, and negative category. Data source and web scraping. The data was extracted from the publicly available review page of Sunway Lagoon on TripAdvisor, Klook and Google Map. An automated scraping process was used to collect review text, rating, and review dates. The data was then cleaned to remove incomplete entry and stored in the master dataset for analysis.
Hi, I am AZIEMAH. For my part, I will explain the end-to-end sentiment analysis process, starting from data cleaning until visualization. First, we use Read Excel to import raw customer reviews. At this stage, the data may contain noise such as symbols, extra spaces, and duplicate reviews. Next, we apply a cleaning sub-process to remove unnecessary character. This includes removing hash symbols, special character, and trimming extra spaces to ensure consistent text formatting. Then after cleaning, we use remove duplicates so that each customer reviews is counted only once and does not bias the analysis. The clean dataset is then exported using write CSV, which become the input for text processing and modeling. Okay, next we read the CSV file and filter the relevant example. The review attribute is converted from nominal to text so it can be processed by text mining operator. So using the process document, the text is tokenized, then text transform to lowercase, then we filter stopword, replace token to handle typos, and the reviews are transformed into numerical features. Next, the sentiment label is extracted and missing values are handled to ensure the dataset is complete. So, as you can see here, I have listed down the word with the scores. So next, for modeling, we use multiply to apply multiple models in parallel on the same dataset. So here, we apply KNN, polynomial by binomial classification, and deep learning, each evaluated using cross-validation. At this stage, we focus on the modeling process, not on the comparing result. So finally, we generate a word list, sort it by frequency, and visualize it as word cloud. So this word cloud highlights commonly used word in customer reviews and help summarize overall sentiment. So here's the word cloud. So this is the result from our word cloud. This is from total. Okay, this is the result for negative. This is the result from neutral. This is the result for positive. And this is the result for in documents. So that's conclude my part of the sentiment analysis workflow. Thank you.
Assalamualaikum and hi, my name is HAFIZAH binti AHMAD ZAMBRI. My metric number is 2022920041. I would like to present about machine learning models. Firstly is K-nearest neighbor, KNN. KNN is an instance-based learning algorithm that classifies review based on similarity. It performs well in detecting positive sentiment, achieving accuracy of 73.26%. Second is polynomial by binomial classification. This model uses polynomial-based classification to handle multi-class sentiment analysis. It is particularly effective for neutral sentiment with an overall accuracy of 72.37%. Third is deep learning. The deep learning model learns complex patterns in text and achieves the highest accuracy of 75.60%. It performs strongly for both positive and negative sentiment. Next, model performance explanation. First, K-nearest neighbor, KNN. Firstly, It's simple and easy to understand. Performs well for positive sentiment. It is sensitive to noisy and imbalanced data. Fourth is less effective for negative sentiment. The second one for polynomial by binomial classification. First point is good at identifying neutral sentiment. Second, handles multi-class classification, slightly lower overall accuracy. Fourth is limited in capturing complex text patterns. The third models is deep learning. First is learns complex and non-linear patterns. Best overall accuracy and balance. Strong for positive and negative sentiment, and lastly struggle with neutral sentiment. Deep learning performs best overall, while KNN, K nearest neighbor, and polynomial models shows specific strengths but also clear limitation. Next is about model evaluation result. The picture shows the highest accuracy is firstly is deep learning. Deep learning is high accuracy 75.60%, most balanced performance overall, strong call for positive sentiment, which is 80.62%. Negative sentiment is 75.36%, and the weakest in neutral sentiment detection is 52.38%. Second is K nearest neighbor. Accuracy is 73.26%. Very strong for positive sentiment, which is 86.25% recall. Weaker for negative sentiment, which is 55.24% recall. And moderate performance for neutral sentiment, which is 69%. The third one is polynomial by binomial classification. This is the lowest accuracy, which is 72.37%. Best at detecting neutral sentiment, which is 82.14%. And lastly, less consistent for positive and negative sentiments. Next, for confusion metric analysis. First is true positive. Deep learning and KNN correctly classified most positive reviews. Polynomial and binomial classification achieved the highest correct prediction for neutral sentiment. Second is classification error. This is the most error occurred in neutral reviews, which were often misclassified. KNN misclassified some negative reviews as positive, while deep learning shows fewer overall errors. Next, for test data prediction n equal to 50. The trend model was applied to 50 unseen online reviews of Sunway Lagoon theme park collected from Google Reviews, Klook, and TripAdvisor. Positive is 70%, neutral is 15%, negative is 15%. What it means is most visitors had a positive experience at Sunway Lagoon theme park. A smaller portion of reviews express and mixed opinions. Only a limited number of reviews reflected dissatisfaction or service issues. And for conclusion, the prediction result indicate overall high customer satisfaction with some areas that may require improvement. Lastly, for conclusion, this project applies sentiment analysis to online reviews of Sunway Lagoon theme park from Google Reviews, Klook, and TripAdvisor. Customer opinions were classified as positive, neutral, or negative using k-nearest neighbor (KNN), binomial classification, and deep learning models. The deep learning models perform the best with 75.6% accuracy. KNN excellent at detecting positive sentiment, while the polynomial model was best for neutral sentiment but had the lowest overall accuracy. All models struggle with neutral reviews. Further work could use larger, balanced dataset and more advanced models to improve performance. Thank you.